what I want to talk to you about today is the use of reamers, particularly with regard to motorcycle maintenance, etc. Most of you do a bit of restoration work, and probably a few of you have come across a situation where you push a bush in, you try to put the shaft in, and the shaft won't fit. It's tight, or it won't go in at all, but there's very little metal needs removing, and the tool to do that is the reamer. Now there's various types of reamer, and I'll run through them, but basically the best types of reamer are fixed size reamers. If you can get a reamer to suit the size of shaft and the correct fit of the shaft, because when you try using adjustable reamers you can end up with severe problems, and I know a lot of people who've wrecked bushes using them and have had to start again. But anyway, we'll go through and I'll discuss them with you. Okay, well here we see, spread out on the bench, a collection of reamers. 1, 2, 3, 4, 5 box sets, and a collection of, first of all, these little jobs. Right, first off, in front of you there is a taper reamer, not a parallel reamer, taper reamer. These are used for taper pins. They come in a range of sizes which go all the way down to the finest size, which I've got somewhere. There's a smaller one, as you can see, same taper, just keeps on going down until it disappears up its own backside. Right, now then, that's that one. This is a plain hand operated fixed size reamer. Square end drive, use your tap wrench to drive it. Same with all of these hand ones. But you're probably not familiar with these. These are known as D-bits. And the reason they're called D-bits is, if you look at the end, there you have a letter D. And you make them by grinding down to exactly half the diameter, polishing the ends, and putting a slight rake on the end as well, so there's a point is formed here, a cutting edge is formed here. Now these will produce almost as good a finish in a hole as a reamer, but you have to use them on a lathe or a drilling machine. They're commonly used in model engineering, mainly for producing flat bottomed holes. The D-bit does produce a good finish, but you have to run it at slow speeds, put plenty of oil on it. Here's another form of D-bit, but it's actually a reamer for a blast pipe on a model locomotive. That gives you the taper that produces a blast up the chimney. This one I can't remember what it was for, some kind of jet, but that was that one. So these are all homemade. These are commercial items, obviously. And there is, I dug out a taper pin. That there is a taper pin, and that's the reamer to suit it. Actually, the reamer to suit that is in the box. So I'll put these to one, well, not put them to one side. We'll go on to the next sort of reamers that I've got. Here's a neat little box here. These are really good. These are machine reamers, fixed size. The machine reamers, because as you can see, they've got a parallel shank. There's no way you can grip them with a tap wrench, and they work really well. What I told these is the fixed size and the metric, not much good if you're into old English bikes. This is a set of adjustable reamers. As you can see, they're brand new. In fact, some haven't been used. I've got some small ones in here, right down to about 1/4 of an inch, 3/16. These are difficult to use, but we'll explain these later. Right, this will give you some idea. I don't know what this thing's for on here, but you can actually use these as a guide through a long piece of equipment to ensure that the holes are in alignment with each other, if you like. So that's what that one's. Right, I don't know if you've seen this type of reamer before. Again, another hand reamer, and they are great, but they are very limited, very limited. They might as well be fixed size. If you look closely at these, they're all cracked. There you see a crack in the end. What's meant to happen is you're meant to be able to adjust the size by nipping this taper pin into here and it swells up because these are ground right through, but unfortunately they're so brittle they break at the drop of a hat. I think there's very few of these that aren't broken, very few. Oh, there's a one. I'll soon sort that out. But they really are nice to use, and they don't bite, they don't grab, and it's probably because they're spiral. And this is one of the problems with the adjustable reamers. They're not spiral, and there's another one that's fine. So there are quite a few, but they're mainly sizes. The ones that aren't broken are mainly the sizes I don't use, and that tells you a story, doesn't it? But it's true enough. I mean, look at that one, completely broken. They're really brittle. Made in India, and probably not quite. I'd shudder to think what they would cost from a UK manufacturer or a European manufacturer. They'd be extremely expensive because they're not cheap to make those things. Again, most of them are intact, but this box here is more of the same. In fact, this was the first box of these. I never learn easily, and you can see most of them have disappeared now. They're broken. I mean, look at this one, completely pieces of it. This one, absolutely horrible. But again, like I say, nice to use. That one's broken. There you see inside, you see the taper pin that moves up and down to expand the reamer. There's also an expanding reamer there. This is my horror story of reamers. All of these are, well, oh, this is the one that's that the guy bent while he was trying to do a little end, or on I think it was a Royal Enfield. He was trying to turn a Royal Enfield bullet into a Manx Norton, I think, fitting a 12-to-1 piston and Christ knows what else in. He had me taking loads of weight off the piston and so on. He got it running, and he sold it, I think. Probably some poor bugger had blown it up by now. But again, here we have the classic reamers that you probably have. Some of you probably have some, and these are the ones that cause a lot of problems. And you can see in here all manner of blades from them, high-speed steel blades just lying in the bottom of the box. Like I say, it's a disaster story. We'll run through the use of reamers and so on. Okay, well, what I've done here is I've machined this piece of steel out to a bore of 17.39 millimeters or 0.6845 inches. Now then, I have in my hand a bronze bush, which I made a long time ago. Now, as you can see, that won't fit on there, but there is approximately, there you go, 0.687. That's the diameter of that, 0.687. I'll just put this camera down while I adjust the, and hopefully you can see there, 17.46. That's the OD of this bush, which is about 1.5 thousandths of an inch interference fit in the hole in this piece of steel here. Now, for a bush this size, about 1 thousandth of an inch interference between 1 thousandth and 2 thousandths of an inch is all you would need to hold that in. Once you get above an inch, they say 2 thou per inch of diameter interference fit is what you should aim for, and that it tends to work out alright. That, so the bigger the job, the more you allow for press fit. If you get too much, the press fit becomes unbearably difficult and you can damage stuff, so you have to be pretty accurate. But I'm fairly sure that this isn't too bad. So what I'll do is, next I will turn a piece of stock up that is a very close fit in there before it's pushed into the steel, and we'll see what happens. We'll see whether it actually shrinks the bore, and it'll demonstrate what happens when you press in a small end bush and then try the gudgeon pin in from the piston and it won't fit. What I've done is I have machined this piece of metal to be a good fit in the bearing here. You can see it doesn't slide, but it rotates. I could take this out of here and hold it upside down and it would stay on the shaft. So we'll see what happens when I press the bearing in. Okay, well, when you're using a press to push a bearing in, it's important that you keep it all square. If you don't, you'll soon tell when it's off square. It gets harder to press in, and you usually get shavings of bearing metal around the outside of the hole where it's pushing tight against the side. And now you can see the bearing just sitting in the top of the bush, or in the top of the housing. It's sitting in the top of the housing, and there we go. We'll start pressing it in, and you can see it's not taking much force actually to press it in. It's getting a bit better. You can see there it's probably a couple of £100 of force, maybe a little more. I don't know. It's coming up anyway, and the bearing's gone in without any trouble really. It'll tell me when it's at the bottom, because that's it there. That's it, fully home. And we'll release the pressure, and then we'll go and take a look. And there you can see the bearing is right the way through at the bottom, and there's no signs of any shavings of the bearing, so it's gone in properly. So let's go and find the spindle that I made, or the shaft that I made, and we'll try it in and see what we get. And there you go. I cannot get that into there, and that's the side, that's the end I was trying, that pushed into the bearing. It's a little bit easier at that end, not a great deal, but that it's just entering at that end. But at this end, it's really pretty solid. So that demonstrates that when you push a bearing into a housing, it does shrink the bearing. Now then, a word of warning about shrinking, putting bearings in. Do not do this. Do not push a bearing into an aluminium housing. Always heat the housing up to around about 100 degrees, or between 100 and 200 degrees Celsius. That way the metal expands, and you'll find these will drop in, and as the metal cools, it grips. But it does exactly the same thing. It will shrink the bearing, not so much as it does when you press it in like this. Now then, I've been looking in the box of magic tricks here, and as luck would have it, this, bearing in mind what I've said earlier, these are beautiful to use, it would be perfect for this. As you can see, it's just about to enter into the bore. In fact, it's a good way in without trying. So there's very little needs doing to actually ream that out. I would slacken this off a little. There's little flats on that screw, and that would reduce the diameter by, I don't know, very little. And then I would enter it into the bore and just slightly nip that screw up, which pushes the taper down inside and expands this a little bit, and keep going until I got the right size. But what I want to demonstrate is how horrible these things are. I've got loads of them, and this one's about as close as I can get it. I found this in my, more or less what I would class as my scrap box. So I'm going to show you how to use these, because these are what most of you buy, and these are what cause most of the bloody problems for people. As I say, they're parallel, they grab, they snatch, they're horrible. But the first thing I want to do is slide these down, loosen this off, slide these down till it goes through the bore, and then I will slowly move the collars up to push these parallel cutter blades up the taper and to increase the diameter. So I'll put the camera down while I do that. Now that is just starting to bite. It's definitely doing something there. In fact, now then, I just had, what happens is, somehow it jams up, and you can see here it's jamming up. It's just catching, which tells me it's cutting just about anyway. But if it really bites and you can't move it, go back the way. And if you adjust it and it keeps doing that, don't try to keep it turning clockwise. Go backwards with it, and eventually you'll either bruise the metal to the point where it works and it leaves a good finish, and you know, you will get there. But if you can rotate it clockwise, which is a correct direction, then fine, you know. I'm not using the tap wrench on this, I'm just using the vise as it's nice and easy to hold. I'm going to give it one more bite and then I'll try the, and when you're adjusting these, honestly, not much more than a quarter turn each one, because they are very fussy things. And again, this one's actually behaving quite well, as it's doing something. But I'm managing to get it to turn clockwise. I've only had to turn it back the way, but you can see along the edge here, you can see a very fine sort of dusty layer of phosphor bronze there. So I'm going to get that shaft and try it. Well, I've just tried the shaft in there and it doesn't fit yet. As you can see, it's not going in there. Hopefully you can see. I'm going backwards with it, as you can see, and it's still cutting, but not very well. And let's see. Still not there. Okay, let's try it with the camera in the tripod, because I can't do anything single-handed here. As I said, I've done 3 or 4 attempts to get this to fit on here, or to ream through here, but it's not playing ball. It's been a bit awkward. However, as you can see, I can't get it on there. But the next phase is just to keep opening it up. If it won't go forwards like that, then run it backwards. You feel it, they bite like hell. They're horrible. And don't be scared by the finish. The work, honestly, trust me. There we go. I'll take these up a bit more. Like I say, quarter of a turn, not much more on each of these collars, because otherwise you just jam it up totally. So there we go. There we go. And another. And as you can see, I'm not really managing very well to do any real work with this. They're horrible, these things, but they do work, but you've got to play around with them. Right, let's try this. Now that really bit there, when I try to go forwards I could hear it cutting, so bring it out backwards and try the shaft again. You do shrink them quite a bit when you press them in. Yeah, I don't know anyone that knows the secret how to use these things properly. I don't think there's a proper way to use them. I'll give it another quarter turn. There we go. And when you're trying to get the enter, go in reverse. And again, it's biting a bit. So I'll put that on there, and we'll use the and it's going down through there. I'm just going to pop this all the way through one way, and there we go. try it's given quite a good finish in there, but it's still not cutting off. So it just shows you just got to keep going with the damn things. If you're using these on phosphor bronze, you don't really need any lubricant. It might help, it might not. I personally don't think it will. But if you're using it on steel, yes, plenty of lubricating oil, and very carefully work your way down through the different sizes. As you can see now, I'm using a tap wrench because it's taking a lot of getting through. And there we go, that's another pass almost through. And I'll try it. No, it's starting to bite a little bit there now, so maybe one more cut. Well, I can assure you I am absolutely sweating. This will probably be the last pass through here. Oops, I'm going the right way for a change, and it was actually cutting. But I think this should do it. Once this has been through here, this pass, hopefully. There you can see the bearing. You couldn't see very well at that other angle I was at, but there it is. That's it reamed out. I don't know if I can get a shot of the finish inside. I doubt it very much, but you can't really see it very well. But yeah, you can see it. It's got a good finish, a good bearing finish. But I tell you what, it's hard work. It really is hard work, that. With this other type of reamer, literally it would have been done in seconds what I've done there. It's just I wanted to demonstrate these because the adjustable reamers, the adjustable parallel reamers, this type, just to show you how bloody awkward they are. Horrible. But anyway, that's that one, and I'll show you the other types of reamer in action. Okay, well, I happen to have found a very small expanding reamer of the horrible type, and I've got here a piece of cast iron, which this is just entering. And cast iron is a different beast altogether. It should, if I can get this into the tap wrench, it should ream through in the forward position once I get moving, but I had it doing that before, but it's not, even then it's not willing to. I mean, these things are just awful, really terrible things. I really did have that going quite well before, and I took it out to, I'm going to reduce the diameter on it just a tiny bit. Try and get it to go in the right direction. Here we go. Nope, it just does not want to go. These are useless things. I mean, you should be able to turn them forwards, but you can't. This is cast iron, and that's it through. Cast iron usually is quite easy to do, and it normally reams quite easily. You don't need lubricant on cast iron either. It's self-lubricating, it's got lots of graphite in it, and you can see that's still, that is actually, I'm actually turning that the correct way through there. I find that almost impossible to believe, but when I first tried it in, before I shrunk it a bit, it was binding up, but this time it's going through quite nicely, and you can feel that it's doing some good there. I haven't got a shaft to try in it. I just thought I would demonstrate cast iron, and the finish in there is really quite good. I don't think you'll be able to see it unless I could maybe try it, although light might help, I don't know. Let's see. But that's a very small one, and it works, you know, it's going through, but such a fussy job. So next thing I'll try, we'll try other types of reamer. Well, the machine reamers, I'll show you them maybe. They're pretty good, pretty easy to use. I'll get round to the lathe and we'll sort something out there. Now then, I've got in here an 8mm machine reamer. This is a piece of EN24, I believe. There's a hole in there that's probably a thou or two under size. I'll put plenty of oil on here. There we go. Plenty of oil on, and you want slow speed in the correct direction, which is clockwise, and a fairly high feed rate. I'll push it there because I'm hard up against the, and there you can see the idea is don't dwell. That's running off centre because I just found a piece that wasn't already in the lathe. But run it through, good high feed rate, right the way through, and then you can bring it back out. If it's cutting a lot of metal, don't try to go through all in one shot because the flutes will bind up with cuttings and you'll get nowhere with it. So there we go, that's that one done. Next I'll try and show you here's one of the D bits. Hopefully you can see in there, there's a very good finish. It's a really nice finish that produces. Same right the way through. So there's so little to come off there, but it was, it reamed out nicely. Okay, well I'm going to put a D bit into this piece of brass. The reason I'm using brass is these aren't exactly, they're not very tough. In fact this one probably is, it's made from high speed steel, but quite a lot of them are just carbon steel, high carbon steel that's been heat treated. So first of all, to get them to run, and I've just put the drill I was going to go with, you have to use a centre drill to get them to take. In other words, you have to have a starter hole of roughly the same diameter or slightly larger. So, turn that up. Again, brass is a material that you don't need to use lubricant on. In fact, it can have a bad effect on it. Things will just skate. Okay, so that's my starter hole done, and now we'll try with the reamer, the D-bit rather, and see whether we can get it to start and drill a hole without complaining too much. It's not quite big enough that hole, but we'll see. There we go. And you can see it's cutting quite well. It's now past the point that the centre drill got to, and you have to really keep backing them out and moving them in again to clear the cuttings, because there's very little clearance for it. That's about 3/4 of an inch deep in there now. So what I'll do is I'll pop that off and try and get to see what it's like inside. Hopefully you can see in there the sort of counter bore where the centre drill went in probably too far, and it was slightly larger than the diameter of the D bit. But you should be able to see, hopefully, down that bore that it's a really good finish. It's a bit wide at this end. I'll just open that up with a deburring tool so we can see at that end what the finish is like. And you can see it's a very good finish in there. Probably as good as you'd get with a reamer. So that's a D-bit explained for you. The taper ones, you use exactly the same. You just put a starter hole in, the minimum size you needed, and then slowly open it up in stages. But they're no different to any of the other types of D-bit. Again, you still have to keep withdrawing the bit regularly to clear the cuttings out. While the CNC mill is grinding away and doing a few more clamps for Peter, I just want to add to the end of this video a few sort of tips on reamers and materials and the uses of. Lubrication is important on steel. All steels need lubrication, including stainless steel. Usually any kind of lubricating oil is good for that, and sometimes even like a tapping compound is good. Cast iron, along with any of the cast bronzes that have a brittle nature, and brasses, don't need lubrication. They cut nice and freely and probably respond best of all to reamers. When you get onto some of the drawn phosphor bronzes, they become very sticky, and possibly some lubrication required there. So I would use again a lube oil of some description. Aluminium, I like to use WD-40 on aluminium. It gives a great finish, or paraffin, or a mixture of light oil and paraffin. Doesn't do too badly either. Material wise, you should aim to have, or to not have to cut more than 15 thousandths of an inch off the diameter of a hole, or increase it by 15 thousandths. Any more than that and you'll possibly run into troubles, particularly with the flutes of the reamer binding up and filling up with cuttings. So it's always best, when you feel that it is taking deep cuts or heavier cuts, to keep the tool on the move. Give it a good feed, but keep it pulling back, you know, go in 1/4 of an inch pull out all the way, clean the end, and then keep going until you get it right through your bush. That sounds terrible. Through the bushing, sorry. But anyway, that summarises more or less the use of them. My recommendation is, if you can get the right size reamer to suit the bearing, that's fine. If you're a genius, or if you're making lots of bushes for the same sort of job, you should be able to eventually machine them in your lathe so that when you press them in, they become a perfect fit. But I've only done that once or twice in my time. It takes a lot of doing. Again, another thing, when you're reaming blind bushes, you need to be careful what you're doing, because the reamers have got a taper section on the tip. Most of them have. The nearest ones you'll get to that or the machine reamers, which seem to be pretty parallel all the way. And again, opening up a blind bush is not easy, so you might want to practice with trying to machine it the right size in the first place. But that takes, as I say, quite a lot of doing. So hopefully you learned something tonight. Probably that I'm crap at filming, but never mind. Next time we'll have a look at something else in the workshop, or workshop practices. Until then, bye bye.